So the main reason we wanted to do finding success with machine vision, I've spent about 15 years in this industry, and a lot of that's been around product quality with machine vision, 2D, 3D laser profiling, and things like that. So kind of giving a background on why I'm someone who should be speaking on this. I've been working with customers for many years in this space, and I know when quality problems happen within a plant, it's stressful, right? I mean, you guys are dealing with a customer who's not happy, and you're trying to find a quick solution to make it stop. So when I typically get called in, it's, hey, I need to put something in place to make sure that we're looking at 100% inspection to make sure that this doesn't get out the door again. And there's a tight timeline on that. It's a stressful time to address it and make sure that we can do that quickly. And I've found that, over the past, call it 20 years, there's a lot of, history around machine vision where maybe people didn't have that great of an experience. And I thought it'd be interesting to talk about ways in which we know confidently you can have success with machine vision. It's an area that we're very proud of as a provider here in Tampa. We cover most of the Southeast, and we have a lot of experience under the roof that feel confident in being able to provide these solutions. So I'll jump into it. My contact information is here, but I'll also have it at the end so you can take a look at it then too if you want to reach out. As Nate said, we'll take some questions at the end if anyone wants to get into any of this stuff. So why use 2D, 3D machine vision for just in general, right? So gauging measurements, tolerances, many times we'll get called in and say, hey, I just need to make sure that this product is to these specs and within these tolerances to what I said they were going to be, right? Per a print or per, a lot of customers might not know exactly what it needs to be, but they know, we need to create that spec together and then hold the process accountable for that level of quality. Inspecting for visual defects, that's obvious, but we've also in many years, or in the last few years, with the onset of the AI and deep learning, edge learning phase that we're into in machine vision, there's been a lot that we are able to do now that we would not have been able to do even as early as a few years ago. Robotic guided vision, so that's more of a camera guiding a robot, or vision guided robotics where the inverse is happening where you have a robot holding a camera. Reading, grading, or validating barcodes, we could do a whole webinar on this alone, but many customers want to make sure that, hey, this barcode is going to be able to be read at the customer site. It needs to be an A, B, or a C. So that's more along the lines of being able to read or grade. Validating to ISO standards, we get into that as well. Optical character recognition, so let's say we have an expiration date on a product and we want to read an alphanumeric string. We can do that with OCR. Presence absence, pretty straightforward, but a good example of that would be, if I want to make sure that cap is on this bottle, the label's on this bottle, so on and so forth. And then assembly checks. I'm putting a kit out and I need to make sure that product A, B, and C are all in the kit before we send it out to a customer. There's many more examples that fall within this realm. This is probably the largest grouping of applications that we deal with on a regular basis. So what does machine vision do, right? I mean, at the end of the day, we're trying to make sure that stuff that we used to do with an operator where they would look at these things on the line or at the end of the line, we can do that in line at high speeds potentially and trying to get 100% inspection. So there's an acronym called GIGI or GG, depending on who you talk to, but that's used to guide, identify, gauge, and inspect. So we're going to show a few examples here of how we've done that with customers over the last few years. We talked about robotic guided vision, vision guided robotics. Here's a good example of that. So in a guidance application, this is one where we worked with a customer. They needed to make sure that certain parts were in certain areas, but on top of being able to do, this is where Cognex, who we're a distributor for, an integrator for, really thrives in such that you can do the inspections as well as the guidance for the robots. Every robot manufacturer will have their camera brand, for example, and typically, no matter who that is, it's for guiding parts and guiding the pick of the robot off of, say, a moving conveyor. Now, in this case, we're able to do inspections on top of the guidance. So that's, critical here. So this is an example where we're doing certain checks to make sure that critical components are present, but we're also able to guide the robot and do different things that we need to do there. We represent Cognex, and we represent a number of different robot brands, but UR in the collaborative space is obviously making a big name for themselves. Cognex has a UR cap to make that even easier to do, but you could do that with any robot brand. We also represent Epson, Kawasaki, Mechademic. We could do that over TCP/IP. So that's another way to get that done. And what that really entails is calibrating the workspace and turning those units from pixels to millimeters or inches, and then maybe needing to incorporate some encoder feedback or conveyor tracking or something like that. But it's pretty straightforward. We can do that, and we can also train you on how to do that. Identify. So we talked about barcodes, and we talked about OCR strings. So this is an example of Ben under the Adams umbrella on our training and service side, worked on this application, I believe a few years ago. And these are Visa gift cards. Don't try to run these numbers and use them. They're not valid. But a good example here, and I'll show a quick video, and I'll try to put it on mute if I can. This is in slow motion, but these are going by at pretty high speeds, and I'll show that in a minute. But what we're doing here is trying to make those characters pop. As you can see, and this is familiar with anybody that's ever owned a debit or credit card. So, being able to light that so that you create contrast on those letters and numbers becomes difficult. So what we did here is we're actually taking 4 different images and allowing those to pop off the card and applying a filter so that it comes across like this. And this is the benefit of working with experts in this space, is that you can make something that's a fairly difficult application like this. It's probably feasible, but when your customer is going to put any custom background in the background of these numbers, that could become challenging. With doing this approach, you really black out anything in the background, and those white characters come to the foreground, and it makes it very easy no matter what that background looks like. This is a video of this going at full speed, just so you can get an idea of the speed and scale of what we're doing here. We have many applications where we're going at higher speeds, slower speeds, but when you consider that our experts are in the field seeing about 10 customers a week, and we've been doing this for many years, you find yourselves in a lot of different scenarios with customers. So moving on to gauging. Gauging obviously is critical when you're trying to inspect to a tolerance. This is an example of an application we worked on with a customer where they needed to measure from the center point out to the outer edges to make sure that it was concentric and in tolerance. As you can see here, we're taking many, many, many inspection points throughout that to get a concentricity measurement. This is another example of a product that everyone's familiar with. So if you go to Publix, for example, and you buy steak and you see that white pad underneath the meat that you never realized what that's for before, or who makes it or anything like that, this is actually that customer. I'll show an example here. Try to mute that. So these are pads that need to make sure there's uniform spacing between all of them so that when they slip these there, that it's going to be accurate. You can see at that video, these are going at extremely high speeds, and we're able to inspect 100% of those across that web. So those are applications where we get involved too. And our experts will meet with you to determine, what is the tolerance you're trying to hit? How can we mount? You'll notice there's a backlight used here, and not all applications can use a backlight. So we'll work with you on trying to figure out how to best get that done. And just overall inspection. As I mentioned before, with deep learning, edge learning, you're getting a lot of that quote unquote AI aspects out of these systems now, where you're able to see defects that you may not have been able to see in the past. In the past, we might have had to try to look at a certain area for a contrast or pixel value or a blob tool to try to see, just defects that may have clumped up in an area that we might know it might happen here. Now with this technology, you could be looking for, let's say, for example, here you have like a scratch, right? Well, a scratch can look different. It could be located anywhere. It could be any different size, and it's never going to look the same. But with these, you can show examples of good parts. You can either take bad parts off the line, or you can mimic bad parts to give the camera examples of what that could look like. And then we're able to train a neural network or use our edge learning devices to train on good and bad parts on your actual product and make pass-fail decisions from there. A good example of that would be here. This was for a customer, and I can't talk a whole lot about the application other than these are ports on the bottom of IV bags. And we're just looking for, is there a rubber cover there on the left and aluminum foil on the right? And this is a dynamic application where we're just doing some testing. But you can see very quickly, you can classify things as this is what it looks like with foil, without foil, and very quickly get that feedback. And now again here with the rubber cover on the left. So those are things that in the past, it might have been hard to classify that. I would have had to probably try to do a pixel value or a contrast value on the left and try to train a pattern on the right. It may have worked, it may not have been as effective as what you can do with the deep and edge learning technology. So where do I begin? Everybody's problems when they come about quality are going to be different, or maybe you're just trying to be proactive about it. Really, if you're not familiar in this space, I would encourage you to lean on experts. We work together to find out what are your application limitations. So, myself or one of our experts will come out and meet with you. We want to look at what's the line speed, what quality issues have you had, what are you trying to detect, what happens when that happens to your plant, and how can we prevent that? So we're going to look at things like how many products per minute are coming down the line. We're going to look at how much space we have over, let's say, the conveyor, for example. We may even look at, is this something that we want to do some batch inspection on, where we do some offline inspection to test one at the beginning of a run and one at the end of the run, maybe grab one in the middle of a run. So there's a number of different ways that we can do this. That could be lasers, that could be cameras. Really what we want to do is understand the problem and not come in the door with already trying to shove a solution down your throat. So we're trying to meet with you and consult and figure out the best way to do that. What you need to do at that point is determine the resolution needed, the lighting needed, and the methodology of that lighting, which is critical for any inspection. I'd say anyone who's ever tried to go cheap with the lighting on an application has probably learned the hard way. That's not where you want to skimp. And then lensing. So all those together we call image formation. That's something that we do in our lab on your parts. And I'll show an example of that in a minute. But a lot of people are out there in the industry, they don't have the resources that we have. They don't have the vision lab that we have, which is well over 6 figures if you want to invest in that. So an easy way for people to go out there and make sure that it's going to work is they'll just try to throw a ton of resolution at you. The reason you don't want to do that is resolution, is the #1 cost in factor in driving up the price of cameras. So you're going to pay for resolution, just like we pay for resolution when you go to shop for a TV, right? So what we want to do is use the least amount of resolution that we know will fit the application to keep your costs down. And then we will determine the lighting and lensing needed with the field of view that you need, within the working distance that we know we have space for, that we came out and factored in when we went out on our visit. So I mentioned our vision lab. Our vision lab is where we're going to do that. We'll take in parts from our customers and we'll select what resolution that is needed. We know, for example, with traditional tools, we typically want to use 30 characters or 30 pixels vertically across every character. We know how much segmentation is ideal for us to be able to determine those things. Now with deep learning and edge learning, we have even more capabilities in that realm, but there's rules that, that's kind of tribal knowledge for our experts that have been doing this a very long time, where we know what we'll feel comfortable deploying. And whether that's that your team is doing it or our team's doing it, we take the same approach. So we'll dial up the resolution, lighting, lensing, and then we'll provide a report. That report will show exactly what you see here in the lower right, So maybe you're trying to do an OCR on lot and expiration date. Maybe you're trying to read this barcode above it, but we'll show examples of what that looks like with what we've sized up for your application. So that's going to show the tools actually doing the inspection that you determined was necessary. We're going to show which camera we used. We're going to show a lot of detail here, but the key things you want to take a look at is how many frames per second, the field of view in millimeters. So that's something that we determined together at the beginning of the process. The working distance, which is going to be from the front of the lens down to your part, what size lens that was, and then your pixels per millimeter and your acquisition time. So those are all things that we work together to determine on the front end that we want to reinforce on the back end and show you that this is really custom tailored to your application. To talk about this briefly, if it's something that will take us a day's work or less, we do that for free as a service to our customers, and then we'll quote you on what that solution looks like. If it's something that takes us multiple days or even weeks, because we have had applications that go that route, what we'll do is come up with an NRE or engineering study type agreement where we say, hey, we're going to charge you for X amount of time to give you a really detailed report on what that feasibility looks like, and then we can determine a path forward from there. So we have gone down that path with customers pretty often as well. So the tools at our disposal, I'd like to say that Adams is kind of a catch-all in this space. We can work with traditional machine vision tools, which is very rules-based and rigid and still very viable or applicable in certain applications. Deep learning, edge learning, we do have lower cost vision sensors. Those vision sensors can also be rules-based. They can also be edge learning based as well. So we do have both the high end of what you need, but I don't want our reputation to be that, oh, we're just the experts. We go out and only do the expensive stuff. No, we'll just sell you the hardware on the low end too and come out and demo that on site with one of our experts that will come out and show that to you. And then we'll do barcode readers as well. That could be handheld, fixed mount. We also have verifiers. And then on top of this, we also have laser, 2D, 3D laser profilers. So we can do that to determine quality as well. So then we need to determine, we've now determined the hardware. We need to determine how we're going to implement this on your line or in your facility, right? So typically I recommend to customers, if you're going to have cameras making quality decisions on behalf of your company before they reach your customer, it would be nice to visualize those images in some way, shape, or form, whether that's you're exporting those images out somewhere, you're having them on an HMI. What I have here on the right-hand side is what we call our vision box that Adams produces in-house, and we stock these. But this allows you to have all the controls, typically components that you're going to need in the middle, or inside this enclosure. You're going to have the HMI on the front. So you can plug this into 110, you can bring your Ethernet cable into the bottom, RJ45, and from there you're pretty much up and running. What that HMI will give you is if you want to, you can have a film strip. I typically recommend the last 10 failed images, and this will be a touch screen. So for a periodic check, you can walk up from time to time and just tap on the screen. You know, what do my last 10 failures look like? Is that accurate? Is that not? So it's a nice gut check to have. But you can determine what images you'd like to see on there. You can FTP those or export those images out somewhere. And then we have to determine what do we want to do when the camera does detect a failure. So are we stopping the line? Are we implementing a reject station? There's a number of things that we can do there. Or some people say, hey, if we see 3 failures in a row, stop the line. So we're not stopping for every single failure. And then integrate that into the PLC as well. What I think is our strength above all of that, obviously everything that I've touched on is an area that we're proud of, but I think one of the things that's very nice about working with Adams is we are the only people in the state of Florida that you could come to and say, hey, I just want to buy the hardware, or hey, I want to buy the hardware, go to your training class and deploy it on my own, or I want to have you guys and come in and do this whole thing turnkey. There's nobody else out there in the state that's going to give you those 3 options. So as I said, you can send your parts into the lab. we can work up that BOM for just you to purchase based on how we sized it up in the lab, which, by the way, was a free service that we provided, assuming you just buy the hardware from us at the end. We do have a training class here at Adams in Tampa that we do monthly, and we're starting to do them up in Birmingham, Alabama as well. But we'll also come to your site. So if you have a few people that you want us to do dedicated training around, where we'll cover spreadsheet programming and maybe go into edge learning and deep learning, but then maybe spend a little bit more dedicated time on your parts of your application, we'll do that as well. Or you can say, hey, you know what? You guys are the experts. I don't want to get my hands dirty on this. You guys come in and do it turnkey. And we determine what that scope of work looks like together. And you don't make your last payment and sign off on it until it's operating the way that we agreed to at the beginning. So I did want to touch briefly on this. These are some non-traditional applications that we're starting to see more and more in the machine vision field, and I think you'll see more and more of these probably in the next 5 years. Thermal, we're starting to see that. A lot of the times where you will see it is seal integrity. So there's an example in the upper right there, kind of looks like K-cups or something like that, where you're trying to make sure that a product got sealed all the way around. Hyperspectral imaging is something that you'll see on the bottom there, where we're actually able to classify things by, that's actually on the left, you can see a mixture of meat and fat, wood, plastic. And what that can do is essentially look up the chemical makeup of something by hitting it with every visible and non-visible wave of light, and then creating basically a data cube, as I call it, but it's basically a fingerprint of what each individual thing looks like under that light, under that spectrum of light. So then you can see on the right-hand example there where you can classify meat, fat, wood, plastic. So that you're going to see a lot of that in the food space at the moment to look for contaminants or things that may have gotten where they're not supposed to be. And then CT scan, this is something that just came up recently with a partner of ours that we're working with, but able to even, that's an Apple AirPod that you can see up there in the upper left. And what we're able to do is even see internal components into some of those products and see those features and actually perform measurement, grab measurements on the detailed components on the inside and try to do some sort of inspection that way. So we're seeing that come about, and you can look at those for inline or offline inspections, but seeing more and more of that. And I want to mention that because I don't want customers to just think of us as, hey, only have to go to them with these applications. Bring these to us as well, as we're already working with the partners that are leaders in these spaces to make sure that we can address any of those needs for our customers as well. So that wraps up everything that I wanted to chat about in regards to finding success with machine vision. Once again, there's my contact information, and I'll open it up to any questions that the group may have at this time.
John Flynn. Okay, John, I'm going to take you off mute. You could ask your question. Okay, go ahead, John.
Thanks. I was wondering if we were trying something and we had a couple different companies try it and we weren't able to work, and glare was like a really big factor. What would be kind of your tips as far as lighting goes, or using different kinds of lights in order, if it's an application that glare is a really big component for?
Yeah, so when we run on that in the past, there's a number of different ways to address that, but bandpass filters is one. Using diffuse lighting is another. One thing that Cognex has, it's a great tool, is HDR Plus, which is a software filter almost, where it uses, it kind of evenly illuminates the lighting throughout that field of view. So say you're getting a hot spot, as I would like to call it, in the upper right, it'll kind of evenly spread that out to minimize glare. But the best thing that I can say is probably have us come out there and take a look at it, or send parts into our lab and we can work up something with you. But there's a number of different ways to get that done. And some of that could be accomplished with just your lighting, but also bandpass filters and trying to attack it that way.
All right, if anyone else has a question, just raise your hand and I'll come around and get to you. We had somebody enter a question in the chat. They want to know, when is it best to use PC vision versus smart cameras?
Okay. Yeah, we run into that from time to time in PC visions, which, typically we'll go into Vision Pro with that. But PC vision, from my experience, the times that we go that way, it's really two events. It's one, you have such a high number of recipes that we need to manage that effectively, and that's not the best place to do that with smart cameras. And two is high speeds. So let's say there are beverage manufacturers, I won't use names, that they'll go, north of 1,000 parts per minute. At that point, we want to bring the processing power from a PC, and we want to go in that direction. And that's typically going to exceed the speeds that you could accomplish with smart cameras.
All right, anyone else with any questions, just raise your hands. I'll unmute you and you can ask. Let's see. So far, I don't see anything else. All right, well, if that's it, thank you all for joining. Really appreciate you spending your time with us. We'll reach out with a recording for you guys to watch afterwards. And thank you all, and have a good rest of your day.
Thanks, everybody.